All right, here we have section 1.5, inverse functions and logarithms. So once again, there's our objectives. Roll down here, so we got a couple definitions. So a one-to-one function. A function is one-to-one on this domain if the f of a not equal f of b whenever a is not equal to b. So what that means is that each x value is assigned one specific y value. So you can't have the ordered pairs 2, 1 and 2, 3. Well, that's not a function. You also, though, can't have, let's see, the y values can't repeat. So 2, 2 and 1, 2 don't work because the y values then repeat and the x values are different. So typically what you use is what's referred to as the horizontal line test. So if you graph your function and you try to draw a horizontal line through, it'll be a one-to-one function if that horizontal line only ever touches the graph once. If there's any places in which that horizontal line crosses more than once, it's not one-to-one. So for example, if I draw a parabola, this function is not one-to-one. Simply because if I draw a horizontal line, it hits the graph more than once. All right, so here it says determine whether the functions are one-to-one. So this absolute value of x. So absolute value x has this equation. So this one is no, because I can draw a horizontal line that crosses the graph more than once. Root x looks like this. So this one is yes, because there is no horizontal line that crosses the graph more than once. So the reason you talk about one-to-one is talking about inverses. If you reverse a one-to-one function, you have the inverse of f. And if you compose a function with this inverse in either order, you get x equals x, so the function returns its own value. Okay, so finding inverses. So see the steps here. So first step, you solve the equation y equals f of x for x in terms of y, and then you interchange x and y, and then resolve. So the resulting function will be the y equals f negative 1 of x is the inverse. So example 2 here, show that the function y equals f of x is equal to negative 2x plus 4 is one-to-one, and then find its inverse. So the first thing I need to do is I'll just draw 1, 2, 3, 4. That's the equation of a line that intercepts at 4 with a slope of 1 to negative 2. So there's my equation. So there is no horizontal line that touches more than once. So to find the inverse, you take your original equation. Now these two steps you can actually do in either order. I actually prefer to do the second step first, so switch the variables. And then you're going to resolve for y. So this 4 needs to come across, x minus 4 is equal to negative 2y. And then I need to divide everything by negative 2. So that's negative 1/2 x plus 2 is equal to y. And that's my inverse function. All right, so example 3, graph the one-to-one function with inverse and the line. Okay, so here's my function. So to do the inverse, I flip the variables and then solve. So there's the inverse equation. There's the original equation. So the one-to-one function looks like, or there's the original. Its inverse looks like that. The line y equals x looks like that. So it's just a reflection. No, I actually already did that. That answer right there is that work right there. All right, so logarithmic functions. So a logarithmic function is the inverse of the exponential, so they're used to cancel each other out. Then ln of x is the natural log. It's log base e, and log 10 is the common log. So this ln of x is actually log base e of x, and the log with no number is log base 10 of x. Turn the page. All right. So just logarithm properties. So if your base is greater than 0 and it's not equal to 1, then a raised to the log a of x for x greater than 0. And you have this, so they are equivalent to each other. They both equal x. You can do the same thing with e. E to the ln is equal to x. And then the same thing in the reverse is also true. All right, so example 4, solve for x. So I need to get rid of the natural log, which means everything becomes an exponent on an e. So over here, those cancel. So I'm left with x equals e to the 3t plus 5, and I've solved for x. Okay, so over here, to get rid of the e, I need to take the natural log. So it's going to be ln of, whoops, e to the 2, that's garbage. Ln e to the 2x is equal to the natural log of 10. So over here, once again, ln and e cancel out, so you have 2x is equal to ln 10, and then divide both sides by 2. So ln 10 over 2. Here you've got properties of logarithms. So you have the product rule. So if you have two things that were being multiplied, you can actually separate them with addition or reverse. If you have two things being divided, you separate with subtraction or reverse. And then this is the power rule here, where if your number has an exponent on it and you do a log, the power comes out front. Down here you have the change of base. So this is useful if you need your calculator to do a logarithm that's either not the natural log or the common log, because those are the only two the calculator can do. So down here it just says graph the function log base 2 of x. So this is honestly just a calculator problem. So f of x is the same thing as y. So let's grab our handy dandy calculator. Menu, graph. Oh, sorry, I know the reason that's on there. So we need to do this in change of base because I can't type log base 2 into my calculator. So I'm going to use this rule. So y is equal to the natural log of x over the natural log of 2. And then I can type that into my calculator. So the natural log of x over the natural log of 2, and then draw that, and it looks like that. So something like that. Okay, so example 6 here. So Sarah's going to invest $1,000 in an account that earns 5.25% interest compounded annually. How long will it take the account to reach $2,500? So here's our generic equation. I'm going to fill in my values. So she invests $1,000 at 5.25% interest compounded once per year. And then when is it going to reach $2,500? So the first step is I'm going to divide, well, I'm going to do two things at once. I'm going to divide the 1,000 across, so that's 2.5. And over here I can do that math in parentheses. It's just that value. So to get that out, I need to take the natural log. You could use the common log, I just prefer to use natural log. Now when you do this on the right, the t comes out front because it's the power rule. So then t is equal to the natural log of 2.5 divided by the natural log of 1.0525, and that just goes in our calculator. The natural log of 2.5 divided by the natural log of 1.0525 is 17.9 years. So almost 18 years to get from 1,000 to 2,500. And that is the end of this section.